1.4 is all about fractional expressions. Fractionals, fractions. Right now I'm just going to go over how to do the number fractions that you would have had more at the elementary level. You can't add fractions unless you have a common denominator. I know you can do one like this, 1/3 plus like 2/15. Or let's just make it a 5 instead. Everybody knows that the least common denominator would be 15. Quick way is just multiply those two together, and that's what I'm going to do. I'm just going to take 63 times 42 to find the common denominator. I think that's a pretty fast way of doing it. 2646. 2646. How did I get that, you guys? I just multiplied those two numbers together. In order to go from 63 to 2,646, I multiplied this number by 42. If you do the bottom, you also have to do the top, which gives you 168. I multiplied this one by 63, so I have to also multiply the top by 63. Once we have a common denominator, you can add the top together, which gives you 483 over 2646. I'm hoping if you're in college algebra, you know how to simplify a fraction on your calculator. Your calculator will simplify it for you. So, but 483 divided by 2646 in simplified form is 23 over 126. I'll do one more really quick. Let's say you have 11 over 45 minus 7 over 18. You can't subtract these because you don't have a common denominator. So quickest way is just multiply 45 by 18 and you get 810. I just multiply these two together right here. I got to multiply this one by 18. And I get 198. I have to multiply this one by 45. And I get 315. 198 subtract from 315 is a negative 117 over 810. And that can simplify to negative 13/90. So that's just a quick way to come up with your common denominator. Okay, now on to the next page. We have to simplify. Notice from first page to second page, what's the difference between the first page and the second page? The first page was just a whole bunch of numbers. The second page also has variables. So, whenever you have variables, in order to simplify them, you must factor. You are in college algebra because you were the ones in Algebra 2 that were good at factoring. If you can't factor, you're going to have a very difficult time in this section. So the first thing I'm going to do, you know what some of you are going to do on the test, which I hope not because you're in college algebra, some of you are going to cancel out the r squared and make this r second. You cannot do that. I said you have to factor. The top, I'm going to take out a -1, and I'm going to put it in decreasing order. I'm going to make r to the second, -3r, and a -10. What happens if I did the distributive property? Would I go back to the beginning? You learned in Algebra 2 that it needs to be in decreasing order and your first power must be positive, and that's the reason why I took out the -1. This is in the right order, so I'm good with the bottom. I need to factor the top, so I'm going to leave the -1, but I have to factor the top, and everybody learned how to factor last year. You have an r to the second, so you're going to put an r here and an r here. The innermost factors usually work for the factors of 10, and the innermost factors of 10 are 5 and 2, so I'm going to use 5 and 2, and this is going to be the negative, and this one's going to be positive, so that I get the -3r in the middle. The bottom, all I can do is take out the GCF, and the GCF is r to the third. which gives me an r left for the first term and a 2 left for the second term. I know I'm doing it right because I have an r plus 2 on the top and an r plus 2 on the bottom, and they can cancel out. My final answer is, I'm going to leave the -1 outside. You can distribute it if you want to, but I'm not going to. All over r to the third. Final answer. Lots of factoring. Here you have to factor a lot. Again, whenever you see variables, you know you have to factor. This one right here has no greatest common factor. It's just a difference of 2 perfect squares. I know I need to put a 2x here, and I know I need to put a 2x here. I know it needs to be a +3 and a -3. And I just factored 4x squared minus 9. The bottom one does not have a greatest common factor, but it can be factored. I'm going to put a 2x here and a 1x here. Factors of 6 are 3 and 2. I'm going to put the 3 here and the 2 here, and it's a plus and a plus. And that also gives me a 7x. Times, GCF, I can take an x squared out. I'm going to have a 4x squared plus 6x plus 9. On the bottom, I can take out an x to the 4th, and I'm going to have an 8x to the 3rd minus 27. Okay, we're going to keep going on here. I'm going to copy down 2x plus 3. I'm going to copy down 2x minus 3. I'm going to copy down 2x plus 3. And I'm going to copy down x plus 2 times x squared. And I'm going to see if I can factor this. Factors of 4x are going to be 2x and 2x. 9 are 3 and 3. This makes 6 and this makes 6, which will give us 12. Nope, it cannot be factored. At least I took the greatest common factor out, so I'm just going to leave it the way it is. Okay, I didn't do anything. I haven't really done anything. I just recopied the first numerator and the first denominator and the second numerator, and now comes the second denominator. The x to the 4th is right here. I just copy it down. I have to notice that this is a cube from 1.3, you guys. We learned how to do a cube. When you do a cube, you need a small parenthesis and a large parenthesis from 1.3. 8 is made up of 3 2's, so I know I need to have a 2x here. I know 27 is made up of 3 3's, so I know it needs to have a -3. Remember, if this is a minus, this is a minus. This is 1.3. This is taken out of 1.3. I already used one of the 2's. I need the other 2 2's here and the other 2 x's, and I already need the other 2 9's. If this is a negative, this one's a positive, and this one's 100% a positive, if you remember my notes from 1.3. To remember how to get this middle term right here. To get the middle term, you multiply the 2x and the 3 to make your 6x. Once everything is factored, I can cancel out. Those two are the same. This one and this one are exactly the same. This one and this one are exactly the same. There is no plus or minus for these two, so they're fair game. This one can cancel out. I'm going to have an x squared left on the bottom. As you can see, the whole top is gone, so I'm going to leave a 1 on the top. And on the bottom, I have an x squared left and an x plus 2 left. That's what it takes in order to do some of these problems for the assignment. Okay, now we are adding and subtracting fractions again. When you subtract, you need a common denominator. And as you can see, they have a common denominator. So I can rewrite my denominator as x squared minus 9. On the top, I can just put them up there. You have to finish by looking to see if you can factor. Well, the top, I can take a 5 out, and you're going to get 3 minus x. On the bottom, I can't take a GCF, but it's an x minus 3 and an x plus 3. Okay, now I got to talk about something else that you should know. This is what you should know. 7 divided by 7 equals 1. Do you guys all believe me that 7 divided by 7 equals 1? What about 7 divided by a negative 7? What does that equal? What happens when you divide opposites? What do you get when you divide two opposites? Don't you get a negative 1? So I want to just go back to this page really fast here. Watch this, you guys. When you divide the same thing, 2x plus 3 and 2x plus 3, what happens when you divide them out? Don't they make a 1 here and a 1 here because they're exactly the same? Oops, sorry, I went the wrong way. When you divide them out, it makes a 1, but what happens when you divide the opposites? It makes a negative 1. So let's look over here. This right here is a positive 3. This down here is a negative 3. This up here is a negative x. This down here is a positive x. Aren't these two expressions opposites? What happens if you want to cancel out opposites? What happens? What will you get when you cancel out an opposite? Don't you get a negative 1 when you cancel out an opposite? So don't you have a negative 5 left on the top over an x plus 3 on the bottom? So watch out for the same thing or the opposites in an expression form. Okay, now this one's a little bit harder. You cannot add and subtract these because they do not have the same denominator. One of them is not in factored form, and you have to factor it to t minus 3 and t plus 3. Can't you use the common denominator? Look at how long this problem has to be. Isn't the common denominator a t minus 3 and a t plus 3? This one, and this one. You have to compare them, and you have to be able to go into all of those. So you have to take a t minus 3 and a t plus 3. So what's the difference between the first fraction and the new denominator? Isn't it missing? It has a t up there, but doesn't it missing the t minus 3? This one has a 4t up there, but doesn't it miss the t plus 3? This is what's so cool about it. What happens if I cancel these two back out? Aren't I back to the beginning? That's why you know you're doing it right. This one doesn't need anything. It can keep the 18. So, well, I know I have a t minus 3 and a t plus 3. That's called my common denominator. What's on the top? Distributive property gives me a t squared and a negative 3t plus 4t squared plus 12t. And it also gives me a negative 18, which simplifies to 5t squared plus 9t minus 18 all over t minus 3 and t plus 3. You're not done yet. You might be able to simplify the top by factoring, so I have to keep going. I know, I can put a 5t here and a 1t here. Factors of 18 are 6 and 3, and I know the 6 needs to go and the 3 needs to go here, because looking at your denominators, you want them to cancel out, so you want the t alone divided by the t minus 3 and the t plus 3. And I know I need a positive 9, so I know this one needs to be the positive and this one needs to be a negative so that it makes the positive 9. This one and this one cancels out because they're identical. Identicals make 1, so you're left with 5t minus 6 over t minus 3. Okay, this next one are called complex numbers or complex expressions. A complex fraction is when you have fractions plus a fraction divided by a fraction minus a fraction. All you have to do is like cover up this and just stare at this one and say, I can't add those together until I find a common denominator. And the fastest way to come up with the denominator is to multiply these two together. SR. Well, I know I needed to multiply this one by r, so this one has to be an r. So this is r squared, and this one s, and this one s, so this is s squared. And then what you do is un-x that, and now you're going to do this one. And you're going to just follow the bar. Just follow the bar over there. And you're going to say, wait, the denominator for this one is s squared r squared. S squared r squared. And the common denominator is, you're going to have an r to the 4th here, and you're going to have s to the 4th here. Now, you're just going to put this under one denominator and this under one denominator. So I'm going to come down here and say, well, I know that r squared plus s squared can go under one denominator, SR. And I know that r to the 4th minus s to the 4th can go under s to the r, or s to the 2nd, r to the 2nd. This is going to be on the ACT. You see this big division bar, and you're going to like wig out because you think you have a big fraction divided by another fraction, and you can rewrite it. You can write it as r squared plus s squared divided by rs. Change the division sign to a multiplication sign and flip this to s squared r squared divided by r to the 4th minus s to the 4th. Rewrite r squared plus s squared divided by rs times s squared r squared. And this is a difference of two perfect squares, r to the 2nd minus s to the 2nd, and r to the 2nd plus s to the 2nd. These two are identical, so they can cancel each other out. There are no pluses or minuses, so I can cancel him out, and I can make this an r and an s. My final answer is rs on the top over r squared minus s squared on the bottom. And now some of you will go farther and cancel the r's out, and you can't. One's multiplying an r and an s, and the other one is subtraction, so you cannot do that. Okay, last part for this chapter is called a conjugate. A conjugate. So you learned in math at the beginning of this chapter that 1.2 that you cannot leave a radical in the denominator. So I'm just going to show you, don't do this, just watch. What happens if I multiply the top and the bottom by the square root of x? This is what's going to happen if you just multiply by the square root of x. The square root of x times the square root of x makes x. I got rid of the radical, didn't I? Minus 4 times root x. I didn't get rid of it. I just moved it over to the 4. Everybody see that? So just multiplying by the square root of x does not work. So what do we have to do? We have to multiply by the conjugate. And I'm going to write it down here. The conjugate of the square root of x minus 4 is the square root of x plus 4. The sign in the middle changes. Everybody see that? The square root of x plus 3, the conjugate of the square root of x plus 3, is the square root of x minus 3. The only thing that changes is the sign in the middle. So if I multiply by the conjugand, which is the square root of x plus 4, top and bottom, I have to do the FOIL method. First are the x outside plus 4 root x, inside 3 root x, last is plus 12, divided by, first 2 makes the x, a negative 4 root x, outside makes a positive 4 root x, minus 16. When you multiply by the conjugate, the middle two terms cancel each other out and you no longer have a radical in the denominator. So my final answer to this problem is, like terms, I'm going to have an x plus 7 root x's plus 12 on the top. Everybody see that I just put the 3 root x and the 4 root x together, and x minus 16. That's all you can do. But did I get rid of the radical in the denominator? Let's do one more. You cannot leave a radical in the denominator. I'm going to multiply the top and the bottom by the conjugant, and the conjugant of the square root of x is the square root of x minus 7, and the square root of x minus 7. I'm going to get an x minus 2 root x minus 7 root x plus 14. I'll wait for you to catch up. On the bottom, I'm going to get an x plus 7 root x minus 7 root x minus 49. Goodbye, goodbye. I have x minus 49 left on the bottom. I got rid of my radical. And on the top, I'm going to have x minus 9 root x plus 14. Your assignment for 1.4 is 1 through 23 odds. You also have to do 33, 49, and 50. 1 through 23 odds, 33, 49, and 50.